Now, to convert a decimal number back to binary, what you have to do is successive division by 2. So let's say, as an example, I'm going to convert 14 base 10. So the regular number 14 base 10. So in the decimal number system we're used to. So this is just a regular old number 14. To get that into decimal, you have to say, take your original number 14, divide it by 2, you get 7. Does it have a remainder? No. Then steal a 0 for your least significant digit. Now you take that 7, divide it by 2. Does it have a remainder? Yes. Steal the 1 as your next digit. Take that 3, divide it by 2. Does it have a remainder? Yes. Steal it for your next digit. Take that 1, divide by 2. Does it have a remainder? Yes. And steal that for your last digit. Now you've got to the point where you have nothing here. So you have finished your division. And so you can conclude that 14 in our decimal system is equal to 1110 in the binary system, which is base 2. If you want to double check, which you should always want to double check, then you can look at each of these digits and apply the bases to it, 2 to the 0, 2 squared, 2 cubed, and you can add through to make sure that you get to 14, which you do. So in order to convert from decimal to binary, you have to do successive divisions by 2 and keep the remainders of 1s or 0s. That is just one way of doing it. I do need you to know a longhand method though. It won't be acceptable in this course to just use an app or a web page to get the answer.